بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. نحيي فيكم مرحبا فيكم. Welcome all everyone. I hope that you had a nice break of 1 week of good work, and hopefully that it was also a time for you to recap with all what things standing and left on from the previous weeks. I know that's always challenging and you have a lot of things to do, and I'm happy to hear that you're going good, many of you with the projects, senior projects, because I have a big group of students doing senior projects, if not all of you. And it's good that through our discussions with other senior project supervisors, things are going good. Many people are still not half the way. We had seen 2 groups also, they are quarter the way, which is also worrying. I'm sure that this week will change a lot for many of you. And you're going to recap. Hope for the best. Hope for the best, inshallah. Okay, great. So where did we stop from last time? Okay, so last time we had stopped at the cause and effect diagram. Cause and effect diagram is one of the things that I already had explained before, and I think so it's like a straightforward thing, and we already had discussed it. However, we need to explain it again within this session today. Today, hopefully, we take the cause and effect diagram and the control charts. So the cause and effect diagram, the cause and effect diagram is also called the fishbone diagram. Okay, so this is the other word that is very well popular, used in literature, and the reason is that because it looks like a fish bone, bones of the fish. Okay, so that's the only idea. So Ishikawa is the one who came up with the idea. It's very simple. It's just asking questions to answer. Usually the word why and you need to answer why this happened, and you're going to do that for 4 M's, and these 4 M's are man, machine, material, and method. And you can always add on the fishbone diagram, and they always and now I can see that they had added environment, ethics, things that became popular, and they do not fall under man, machine, material, and method. Okay, so he started with this idea in 1953, and let me say, like, this method was known any long time ago. People knew how to solve problems, so definitely they had their own methodologies, or even methodologies that were very popular thousands of years ago, right? But he came up with an idea of organizing how to do this thing. Okay, and future you're going to find also new ideas. Well, they are not happy with this very basic solving problem technique, and they're going to find another quality control tool. However, this is one of them. The fishbone diagram. Okay, and it became very popular because the guy who made the 7QC tools, not made the 7QC, but he collected the 7QC tools into books. He just made the fishbone diagram run really very fast all over the world. And the thing is that now, is there a picture that I need to use exact lines and symbols for relationship for the cause and effect diagram? No, there's nothing. Is there a correct way to draw the fishbone diagram? No. Okay, so there's not exact thing that we need to know there. What we need to know is that you're going to have a line, which is mainly the problem. And then what are the causes of those problems? What are the causes of this problem? So this is cause number 1, cause number 2, and cause number 3, and cause number 4. Now, we don't call them cause 1, 2, 3, 4. We call them man, method, machine, material. And if I go for a man, for example, then I start here building my fishbone diagram, where I say that, well, for example, the pH reading is varying. Yani is varying, like, for example, it's not fixed. Sometimes it varies and measures pH is equal to 7.5, and then it says 6.5, and then it says 6.8. It's really varying. And then you want to find the reason. It could be, if you go to the man now, it could be that the person who's using the pH meter is not well trained. And now I'm talking about only the man. It could be the person who's reading this pH meter, not well trained. What else I can use? I don't have another example actually, because the main I would say little experience, because and still little experience is related to not well trained to some extent. It's different.
Doctor, maybe we can say that he doesn't pay much attention to the reading. Maybe
Okay.
he's taking them too fast, and he misses a number or something.
So I can say that he's careless and not,
yes, exactly.
Yeah, not attentive to reading, for example, calculations and so on. So now we are talking about all about the man. The word man means man or woman, of course, and you already know this, right? And it's just because it is just because that it is in English, the word man became as a man, yani. But in Arabic, these words usually reflect both the man and the woman. So after we have done that, for example, let's go to the machine. Maybe talking about the machine now, what causes again, what are the causes which cause the effect that the pH reader is not working? Why? That this is the other way of thinking about it. Why the pH reading is varying? The pH reading is varying. Talking about machine, the pH meter is whatever. It is old, not calibrated. The pH meter is what else? Do you have other things in your mind? The pH meter is well, it's old, not calibrated. It is, yeah, these are the things in my head. Okay, whatever. Okay, so let's go to the method. For example, when you do the pH reading, you need to go through a certain method. Why? Because you're dealing with acid and bases, and you also do some kind of dilution. And even the pH meter, you need always to like re-zero it as part of calibration as well. It's not any calibration, it's part of standardizing that the first reading to be at a fixed point. Of course, re-zeroing it is at 7. It's different from re-zeroing at a reference value, which is 0 for other instruments. So in this case, I would say that the method is not standardized and or not written. Okay, and we can put these 2 points, like it's not written. Because it's not written, that this person is using a certain method, and this method, because it is not written, every time he uses a different kind of a method, and he falls into many different errors just because it's not standardized or not written. Okay, and let's go to the material. Okay, here was the machine part. Okay, here was the machine part. You can see I was talking about the machine, the pH meter, here, and not calibrated. How about this side here, the cause number 2? I'm talking about the material. Now talking about the material, that the thing that I am measuring, maybe what I'm trying to measure, the reaction is still not in equilibrium. So there's still some kind of reaction is going on while I'm reading the pH. And this is why it was varying. So I would say that, for example, the reaction is still running. For example, maybe I'm using every time, if I'm talking about samples, my samples, which is something to do with the material, using different, of course, there are different samples, but here I'm talking about, it's like I'm not using standardized samples. Again, the word standardized is not correct. Whatever, you got my point. They are using samples that doesn't have a certain standardized way of dilution. I don't know if you remember the pipette, where we try to standardize with a certain amount of dilution. Like I remember when I used to work with heavy metal ions, one drop. يعني I'm really serious about it. يعني it was only one drop that makes the difference in my reading. One drop. So I needed to be very accurate with each drop. So if I talk about 10 drops, I need to have 10 drops in that metal ion. So what you used to do, we used to go to the roads, and this is a road where you have cars, and you have a lot of we call it غبار, okay? It's just dust. These dusts are full of heavy metal ions. So what we try to do, this was my master degree. We go and collect some samples. So we collect some samples, of course, random from many different places in UK, not in Bahrain. Yani. I wish we can do this in Bahrain. And from many different samples. And then we start analyzing to know the percentage of heavy metal ions. Heavy metal ions, that means we are talking about lead, iron, and many others. And of course, these heavy metal ions, they get what? They get inhaled يعني في التنفس, into the respiratory system. So if they get inhaled to the respiratory system, it could be really dangerous. Of course, it depends on what? It depends on the concentration of these heavy metal ions. And again, what I'm trying to do here is to find these concentrations. Now, to know what is the concentration of heavy metal ion, you need to do a lot of chemical analysis within the lab. Doing a lot of chemical analysis in the lab requires really very high tech, very high skills, person who's very well skilled. So when I started doing this, I had a lot of mistakes and errors just by having few drops added, like 2 drops, and someone told me, you need to be really very accurate. And for example, even when you clean the tube, before you use it, you need to make sure that it doesn't have any drop inside, which could be at the sides. Okay, it's just water, right? You're cleaning it. So you need to put acetone just to make sure that it takes off all the water. It's something to do that it loves water, and then it evaporates. So it gets rid of all the water. So now you need to also to make sure that there's no acetone inside. And so you just leave it for a few seconds, 10 seconds, 15 seconds just to make sure there's no acetone inside. And within this time, you need to make sure that it is like upside down so that there's no dust gets inside. I just explaining that how this thing was tough for doing the experiment. So going back to the pH meter, what I was trying to say about the samples, if you don't use standardized samples or samples that are very well prepared samples, not very well prepared samples, you could have the variation of your reading. So you can see how we are trying to find out the reasons for the problem, or let me talk about the causes of the effect. The effect here is the problem. And these are the causes, cause 1, 2, 3, 4. These are the causes. Now we do organize our causes to be man, machine, method, and material. And those 4 causes are used so that I have I can identify the causes for that pH reading. Now after, if you think about it, why I am doing the cause and effect diagram? I do this because I want to find solutions. And now because I have, for example, in my machine analysis that it is not calibrated. I need to find out, maybe it was calibrated. If I found out that it was not calibrated, that means the solution, part of the solution is to calibrate it. Maybe the person was not well trained, so I'm going to put a solution to train that person. Maybe the method was not written, and every time the person who's using the pH meter is not using a standardized method, so I need to write a standardized procedure. And it could be that the preparation of the samples was not good, and so we also need to do that to have well prepared samples. Or it could be that the reaction is still running, so I need to wait, for example, for 1 minute till the reaction is in equilibrium, and then I could take my reading. So I can come up with many solutions, as you can see here with this cause and effect diagram, this beautiful diagram. So that is the cause and effect diagram, and that is what they call the skeleton, how you form the skeleton of this diagram. Yani that's I have more examples, but do you have any questions before I go to more examples of cause and effect diagram? Things are good. It looks straightforward, right? Then, great. So continuing on, there are some tools which help you for cause and effect diagram. You can draw it by your hand, but I have one of the tools here where you just have, you click. Of course, it's not only this tool. If you go to Microsoft Visio, you will also have something that is also very similar. Now I just clicked here. I just click Fishbone Diagram. Okay, I clicked Fishbone Diagram, and it draws for me. It will not do the analysis for me. It will just give me the drawing for it. So it gives me the drawing, which you can see here in this Excel file, where it says that you have a problem, and in this problem, it's written here, during a certain time, Pareto accounted for 50% of problems, which was 3 times higher than desired and caused customer dissatisfaction. Whatever, there's a problem, okay? I don't need to explain what he's trying to say here. And I'm going to write the causes of those problems. Now, when I write the causes, again, I have when the man, the people, machine, materials, and methods, and they call these the 4 M's. Okay, so they replaced here the word people, as you can see. So I have the 4 M's, and of course, within the methods, for example, I put my first cause, why. Now, you can go further. You can go even further. Yani, the person is not well trained. Okay, not well trained. Then there's another why. Why is this person not well trained? Okay, so why is this person not well trained? You can see this arrow comes out. This arrow comes out from the first one. So now I'm going to a secondary cause. So that was my primary cause. and now I'm going to a secondary cause. So why is this person not okay? I'm talking about machines. Sorry, here's the answer. People. Okay, I should write it here. So why not well trained? Okay. Now, why is this person not well trained? Because there's no training program. Why there's no training program? Of course, you don't need to go why for everything, but if you want to, yani, to go even more depth, why the person is not, there's no training program with this, there's no training department. I'm just giving examples in my head. Okay, why there's no training department, you don't need to go why and why. But the thing that you could have a primary cause, and then a secondary cause, and then a tertiary cause. And of course, if you go to a fourth level, they usually call that a root cause, and you cannot go more than that. Your root cause, of course, could be at a secondary level. But what I'm trying to say is that usually you don't go more than 4. 4 is the maximum. A 4 whys, 4 times say why, and why is more than enough to know the root cause of the problem. Okay, so that is a kind of the 4 M's that we are talking about here, which is a fishbone diagram. Fishbone because you have like, this is the main bone in the middle, and then you have these side bones, and then within each bone you have even side bones, the smaller one bones. Okay, so it looks like a fish, and they call it a fishbone diagram. Of course, there are larger fishbone diagrams. Okay, there are larger fishbone diagrams that you can go through, and you can see here how small I can go to this fishbone diagram. And if you look at it, this is just a drawing done for you by the software. So this is the problem statement, and then I will go to the 4 M's. Now I will realize that there are not only 4 M's. There's the method, process, measurement, material, machine, people, and environment. So I have two additional points that I have here, which are related to the environment and the measurement. So instead of having 4 M's, I'm having like now 6 different causes. Now again, do I need to fix to these 6 different causes? The answer is no. You don't need to fix yourself to that. But you need to fix to the main 4, and then if you would add, you can add any. Okay, so I will say that again, because if the test comes and then you said that I did not use the 4 M's, I used something else. La, you must use the 4 M's, and then if you want to add more, please add if you want. So be careful. The cause and effect diagrams need to include the 4 M's, because through experience, it had been always noted that the 4 M's are the main causes, and of course there could be other causes other than the 4 M's. So that is the fishbone small, that's the fishbone large. There's a fishbone medium, very similar, it's just smaller, with smaller bones, and that's all. Okay, there are more ways of looking at it if you want to make it more complicated. For example, now with this problem statement, you can see that you're looking at the causes at one side, but there are more creative ideas that they use another side of this fishbone diagram where they talk about the barriers. And barriers is something else, but I will not go through this. I'm just opening your mind that there are always different ways of using this fishbone diagrams. Okay, so you always can be creative and use it in a very creative way. Okay, so, and you can add more and more. Whatever points you want to use, you can even add that more and more ideas of how to use this fishbone diagram. So that is the fishbone diagram that we have. The fishbone diagram again, we can look at the cause of the the effect, the problem. I would call it the problem. And within the problem now, we want to find what are the causes of those problems. So I have a quality problem of a certain product, okay? So why do I have a quality problem of a certain product? If I go to the machine, for example, it's out of adjustment. The machine that is used, that are used to make this product, and let me put a name for this product. So this product, I want to produce awal, شو اسمه دي awal cream, okay, the cream that is used for food. Okay, I don't know why I wrote this, because maybe because my wife told me to buy awal cream and I still did not buy it, and maybe that's why it came into my head يعني at the beginning. For boys, I don't know if you know what is awal cream يعني. It is يعني gamer زين قشطة. Okay, so if you don't know what I'm talking about, this is what I'm talking about. If these words make sense for you. So now we are producing that kind of our cream, thickening cream, and it could be the problem that I'm not having a quality in the production. That means I'm having a variation. If I would call, I'm having a variation in my product. Variation in my product could be mean the taste. It could be meaning that it could be, of course, the taste. If I'm talking about, again, the true quality. If I'm talking about the substitute quality is the thickness. Talking about the ingredients. Maybe we talk about now more scientific terms, more technical terms, rather than not talking about the terms that are related to the customer, which are the true characteristics, if you can recall the name, and the substitute characteristics. Now, if I have this problem, what are the causes? It could be that the machine are out of adjustment. It could be the machines are tooling, they have tooling problems. The tools that we are using, there's a problem with them. It could be the machine is very old. They are warning يعني بدي يخترب, okay, يتآكل, okay. So it could be related to things that are related to machine. Going to the human, it happens that there are sometimes where we have a poor supervision. And في أحد بيشارك? Okay, it's okay. I had just heard the microphone on. So it could be that there could be a poor supervision of the supervisor for the operators, or it could be lack of concentration of the operators. Now, why again, right? And you always can ask, why do I have a poor supervision? So you can go to a secondary cause, or going to the lack of concentration of the workers. And now you go to a secondary cause. Why do I have lack of concentration? And there could be a reason that is related, I don't know, any lack of concentration because the lightning, we have a problem with the lightning, for example. The lightning within the rooms are not well used. Maybe there was a problem in this with electricity in that neighborhood where no one got to sleep. I don't know. I'm just getting out anything from my head. So the thing that these are things that are related. It could be because of the supervisor came in the morning, he just screamed at all his workers for no reason, and now we have lack of concentration. And it could be, I'm just guessing, and that could be a reason. So we put secondary reasons, okay? We can put secondary and tertiary reasons. You already can see that there are things which are repeated. I mean, the human, you always have lack of concentration. Training, the word training always comes with a human thing. So when you can't have something in test, you always can use these very clear, obvious points that are repeatable for any kind of a problem So you always can get good marks with this and go ahead with it. Okay, so in-educate training is part of it. So you don't have people who are well trained, and because they're not well trained to use those machines, okay, and maybe they're not well trained to use a certain process and method, so they're not going according to the standardized process. So that because they are not well trained to do those, you don't have a quality product. There could be a problem with the measurements. So we always do some kind of testing. So our testing now has a problem. We have faulty testing equipment, or we have incorrect specifications in our measurements, which we have written, which we thought that we don't have a quality problem. We have a quality problem, and now we found out that we don't have one. Improper methods, we are using methods that are too old, because now we are using new materials, for example. These methods are not proper. Maybe we are using new machines. Okay, so maybe these methods are not proper. Maybe because of the new machines, I need new specifications. Okay, maybe I'm using a new material, so I need a new specification. And maybe because of the new material that I'm using, I need to have a different testing equipment. You can see that like things could be related. So because any part of these elements that I have been changing here, it could be affecting another part of this process. Going to the process, for example, again, the process, why we don't have this good product of our cream. You see how I'm thinking, right? Because if I get stuck, I always go to the word why. I state the problem again. I say I don't have a quality product. Why? Let me go to back to the process. I mean, this is the way of how I do it. I don't know which way if you think about it, but always the word why, it helps a lot, just to streamline your way of thinking so that you have it in the right direction. So going to the process, so you could have a poor process design, and this is why you don't have a quality product, or it could be ineffective quality management. This is why you don't have a product. You have deficiency in the product design. This is why you don't have a quality product. Now you will say that, wallah, يعني awal, it has a design very clearly written. It has a quality management system. Why should I talk about poor design process? It already had a good process. Again, if you have a new machine, maybe you need to change in the design, change in the process design. If you have new materials, maybe you need to have some little few changes here and there within your process. So that is the idea, and this is why you need to look at all your 4 M's. Again, the material, it could be that I'm having a problem with my product because I used to deal with supplier or vendor A, and now I have changed my supplier because he sells, for example, he sells the thickening, the milk powder مثلا يعني. So they sell the milk powder يعني مثلا 10 BD per 100 kg, 100 kilograms. I'm just putting numbers from my head, okay? So they sell 10 BD for 100 kilograms. Now, it happened, for example, that this vendor, because he knows that we as Awal, we always deal with him, so he decided that, well, I'm going to change it to 15 BD. يعني, because of the Corona period, I'm losing somehow, and I'm going to misuse, because I know that I have a monopoly, احتكار, monopoly of this milk powder, and Awal will always buy from me. And then Awal decided that they don't want to go with this kind of vendor, and they're going to take from another vendor, okay? And when they went to another vendor who sells with even less, 5 BD per kg, per 100 kg. So he sells with only 5 dinars only. عجيب, huh? From 10, he took it up to 15, but with another vendor we get even with 5. And then Awal discovered, for example, that this vendor, it has a lot of defects in its milk powder. It's not as fine, as they were expecting. It doesn't have the same particles, this particle size. I don't know if you know these or not, but I'm sure you know. There's a particle size in which you deal with such kind of when you deal with such kind of food processing. You talk about the particle size, about the solution, about the surfactants, and so on. So going back to the idea, just to make it even clearer, يعني, for example, you hear your dad and mom talking about having a new house or buying a new house, and they tell you that this house is not well built and the other house is well built. Or they can tell you that this house is commercial, tijari, which means they used commercial materials in building that house. Okay. And if you think about it, what is a commercial material and what is a normal material? And even if you go for your car to try to fix your car, and they tell you, do you want an original one or a commercial one? تبي أصلي ولا تجاري? So the word commercial, the idea is that it's cheaper and it may have some defects within it. It may not live as much as you expect. So what I'm trying to say is that sometimes changing the vendor would have a problem. And this is why it's written here, defective from vendor. Okay, you change the vendor, you have defects from the vendor. And if you have defects from the vendor, you may have a slight change in your product, which is not accepted to customers. Customers, they always like the same taste, exact taste. They don't want any variations at all within the taste. You just imagine for yourself, you're taking an orange juice, and this orange juice is just different from one day to another. Doesn't make. And Vimto, I was like the example of Vimto. So if Ramadan is coming on and we having Vimto, and imagine that Vimto that you're going to use is always changing. Actually, if you go and see many different products who like to replicate the Vimto, they always fail because they don't have the exact concentration of that, exact specification of that. Okay, so material, it could be defective from the vendor, not to specifications. So the materials are out of specifications. Okay, so you're buying some materials to build your home. You're buying the materials which are part of your product to form your awal cream, but these materials are not to the specifications. Or it could be handling problems. Handling problems, that means I have taken the milk powder, but before I put it into my design process to form this product, I had taken this material, the milk powder, for example, and I store it in a very hot, humid place. And we have a high humidity in Bahrain. So we kept it there for one day before we put it into process, for example. Or we have a big amount of this material, and some of this amount stays for about 2 weeks within the store before it goes through the process design. So what I'm trying to say is that handling the material could cause also the problem that somehow the specifications of my milk powder is changing because of the humidity, or it could be because of the temperature changing some specification of the material, which caused that there's a change in my product. And at the end of that whole process that we are trying to explain here, the environment. Yes, the environment could be very dusty and dirty. Would that affect my product? Yes, it could affect that my product, and we need to. And if you went to Awal, their factory, if you were young. Yani they take us when we were young to, and they gave us at the end of the day milk or juice so that you drink. It was a very nice visit. I like it. And by the way, خلاص, I don't want to say that. I don't have time. Okay, so the environment could be one of the reasons that we don't have that product. And one of the things that they showed us when we were kids, that it was very clean. It was not dusty, not dirty at all. And there was a control of everything. There was a control of temperature. There was control of everything there within that factory. And imagine if you don't have good control, what could happen? There are many things that could happen that would affect the formation of our product. So that is the idea of the fishbone diagram. You always can have many different examples. This is an example, and this is an example. Many different examples that you can have all over and just put cause and effect diagram, and you're going to find full and heaps of examples you're going to find out on the web. Okay, great. So do you have any question before I'm going to finish up this with this any advantages and disadvantages? That's all. I finished my lecture. Do you have any questions? Okay. So if I'm going to talk about the advantages of this cause and effect diagram, the diagram is, of course, education itself. You can learn a lot from it. It demonstrates knowledge of problem-solving team. So you can solve it, of course, by yourself, or you can have a team, because you cannot get the idea of what's happening in the machine side or the material side or the method side. So you always need also a team to work with you. And this is where you need the, it's not that you need the knowledge, it's that it requires that team to sit together so that they can look at all the problems at different directions. It means that the maintenance team is going to sit with the management team, and they're going to sit with the material team, like that. Diagram results in active searches for causes. Of course, you find out causes, which includes, of course, as I said, primary, secondary, tertiary. So you can go till you get to the root cause, and here where you're going to find the solution. Of course, the root cause is not always the fourth one. The root cause can be from the secondary part where you put the solution for the problem. Okay, the last thing is that the diagram is a guide for data collection. It's good. You always can collect the data. Very similar to the affinity diagram. And I know that sometimes you say that شنو الفارق? The affinity diagram, this there are different tools. They have similarities. They have things which are different. Okay, and with time and with experience, you will find out that people learn from each other. So they take from each other some ideas, but then they put it in a certain methodology that becomes very catchy. And this catchy, which makes it marketable. And when it becomes marketable, it becomes a tool for spreading out this kind of idea, which is the cause and effect diagram. So finally, remember that you need to use always the 4 M's, especially when you talk about manufacturing. So you talk about manufacturing, you always talk about man, method, machine, and material. Something to do with manufacture, industries. Okay, these are the kind of the examples that you always go to the man, machine, method, and material. Now, when you go to service applications, you may look at some other points other than the 4 M's. Other than the 4 M's, you may look at the procedures and the policies as well. These actually are methods, and it's still very similar. I needed to be more specific here. The idea that I wanted to add is that other than the 4 M's, you have the popular ones, the environment, plus, I forgot. Okay, so you had the environment measurement. Okay, and measurement is not always used, whatever. And I would add other points which you're going to find maybe on the web, something related to the ethics. Still, ethics is part of methods and procedures, and it's part of the people. But I had seen this in many places. They had been adding ethics. Well, we are talking about adding two parts here: environment and measurement. Okay, environment and measurement. So what usually I do, I ask you to apply. I don't ask you to apply the 4 M's. I ask you to draw the cause and effect diagram. Okay, considering 4 different causes. Okay, and then the main 4 different causes are going to be man, method, machine, and material. And if I ask that with 6 different causes, and then you will know that, well, it will be definitely the 4 M's plus 2 other ones. And the 2 other ones, the most popular ones, are going to be the environment and the measurement. Now, would you select different ones from here? The answer, yes, it is possible. You always can have different ones other than the 4 M's. The 4 M's are the main base for your methods, and then you can add any other 2 that you find most suitable for the problem that you're trying to tackle here. يعطيكم العافية. It had been a good session after this long mid-semester break. I don't know if you call it long or not, but when I was young, this mid-semester break was like, it was the best, one of the best breaks that I always have. But I never stayed in Bahrain in mid-semester breaks. I always had been traveling here and there, and I do my projects also outside there. يعطيكم العافية. I think so. That's all for today. Please see if you have any questions. They are not interested. Shouldn't they? The wrong readings. Okay. Yes. Okay. Doctor, where we can upload the assignment? Okay. So it means that I did not do the job of the upload to the assignment. I didn't know that. Okay. So just let me check. Assigned. I already had returned assignment 3. Okay. Assignment 4 is not there. Okay, assignment 4 is not there. So I would do this plus sign. Sorry, I would do this create sign assignment. So now you're going to have the assignment 4 is going to be available for you to submit it today. The submission is today, صح؟
ايه كثير بس اللي عقب ما عارف.
ليه نص الليل؟ Okay. Today is 12th of April. Today is 11th of April till 11:59 at night. And that's all. I think so. It's fine. Is it fine for everyone to submit today? I think so. It's fair enough. I already told you before, so you're ready for it. Click assign. Everything is good. So now we have assignment 4 to submit. يعطيكم العافية. شكرا جزيلا ونشوفكم على خير إن شاء الله. يلا فون الله. مع السلامة. Thank you very much.